Vectors is one of the most difficult concepts in physics. This is what I listen from students when they learn vectors for the first time. Hello guys, my name is Hitesh. When I was in 11th grade, even I thought vectors to be as an extremely important, extremely difficult concept. Now, is that our problem? No, it's totally not. It's the way in which the vector concept was explained to us. It was explained to be as a very difficult and complicated concept. No, it is absolutely not. It is a very simple yet very important concept which you need to be knowing about in order to solve problems in physics. So in order to avoid that problem in vectors, I'm going to make a video on vectors in form of 3 parts. So this video is the first part of that particular thing. So I want all you to subscribe to my YouTube channel and hit the notification bar for the further updates. So without wasting any time, let's get started. The root meaning of the word vector is carriers. So vector means carriers in the form of root word. Now let us see the definitions of vector. So vector is a physical quantity which has both magnitude, and direction. Now if a physical quantity has only magnitude, it is said to be a scalar. Now if it has both magnitude plus direction, it is said to be a vector. There is one more component of vector which nobody talks about, which is magnitude plus direction plus obeys triangular law of vector addition. So obeys triangular law of vector addition. So if all these 3 criteria are fulfilled, then only a physical quantity is said to be a vector. So now people might be having a doubt of what magnitude means. Suppose I have a force of say 5 newtons towards north. So 5 newtons towards north. Now this is a typical force example. Now in this case you can see the number 5, the numerical value 5. Now this numerical value is called magnitude. Now the direction in which the vector is facing, in this case it is force, it is called the direction, so obvious. Whereas since it obeys the triangular law of vector addition, I can say this particular example is a vector. So now how do you represent the vectors? Vectors are normally represented by using English alphabets. You can either use capital letters or small letters to represent them. In textbooks, they're going to write the alphabet and they're going to make it very bold in order to say it is a vector. Whereas writing in the form of hand, we can't normally replicate this every single time. So in order to avoid that particular tedious task, we're going to write this as a vector A. So if you write an arrow mark on top of a alphabet, it is called a vector. So this is called vector A. So in this particular example, suppose this is vector A. I'm going to write it as vector A is equal to 5 newtons towards north. Now magnitude of vector A is represented by writing. So magnitude of A is represented by writing 2 lines at the sides of the alphabet. So this means magnitude of A, or you can simply write as A. So this is how we represent magnitude of a vector, whereas this is how we represent vector, and this is how we write in normal form. There are different forms which I'm going to discuss later in the particular video. So okay, now let us see what is unit vector means. So as I told you, vector is made up of 2 things, which is direction and magnitude. So vector is direction plus magnitude. Now this, suppose I'm taking an example A, suppose vector A I'm taking an example of. Now this vector, in order to write it mathematically, I told you magnitude, I'm going to write it in this form, whereas direction, I'm going to write it as A cap. Now this A cap, what you're seeing, represents the direction, whereas magnitude of A, what you're seeing here, this represents the magnitude. Now if I divide this, so I have an equation like this into A cap. So this is how we call it, A cap. So if I do some math, I'm gonna get A cap equal to A vector divided by magnitude of A vector. So this is basically what unit vector means. So it represents the direction of particular vector, whereas magnitude of A represents the magnitude, whereas vector A is just vector A, which is combination of both magnitude and direction. So it's very easy to understand. So okay, now let us see how we can represent vectors geographically. So okay, now let us see how we can represent vectors geometrically. So vectors are usually represented by using a line. So suppose, as I told you, vector is made up of 2 things, direction plus magnitude. So the length of this particular line or arrow, so the length of this particular thing represents the magnitude. So length represents the magnitude, and the direction in which the arrow is facing represents the direction of this particular vector. So suppose I have a vector, I can write in this form. So this length correlates with the magnitude of the particular vector, whereas the direction in which the a vector is facing is the direction of this particular vector. Okay, now let us see what this angle between two vector is. So suppose you have two vectors, say this is vector a and this is some random vector b. So in order to find the angle between two vectors, first thing what you're going to do is you're going to merge the tail of these two particular arrows together such a way that you don't have to alter the length or the direction of these two particular vectors. So suppose I'm going to shift this vector over here, I have to write it in this way, whereas if I should shift this particular vector over here, I have to write it in this way. Now the angle between these two, so if you join these two tails, what angle you're going to get here is the angle between two vectors. So this is very important topic because normally students mess with this particular thing. So they normally so this is a, they're gonna do this, and say this is the angle between two vectors. No, this is not the angle between two vectors. Angle between two vectors is when you join their tails without altering the direction or the magnitude, and if you find the angle using protractor or whatever you want, the angle what you get there is the angle between two vectors. So let us solve a problem on this. So there's a problem given over here. So there's a vector with 5 Newton magnitude facing in this direction, whereas one more is facing in this direction. We have to find the angle between these two vectors. So normally people would think 60 is the answer. No, it's absolutely not. Here you can see the tail and head are meeting. It should be not in this way. Only the tail should meet. So we're going to alter this in such a way that both the tails are meeting. So 5 Newton this, and I'm going to shift this particular vector over here. So this is going to be my 5 Newton. So if I use some math, if I use some geometry, this is going to be my 60 degree. Now using some other math, if I call this x, so as you know, the combination of these two is a linear angle which is 180 degree. So 60 plus x plus 60 equal to 180. So x equal to 120. So this is how you're going to find the angle between two vectors. So please don't confuse on this particular topic. So okay, now let us see how we can add two vectors. So as I told you before, you can represent vectors in the form of arrows. So suppose I have this arrow, first one, which I call it as vector A, and now suppose I have one more arrow which I call it as vector B. Suppose we want to add these two vectors. Now you have a special rule or special method in order to add these two particular vectors, which we call it as triangular law of vector addition, which I told you in the beginning. I told you vector means which physical quantity which has both magnitude, direction, plus it obeys triangular law of vector addition. Okay, now let us see how you can add two vectors. So the first thing is you have to see the sequence in which the vectors are added. So suppose the question is vector A plus vector B. So first thing what you're going to do is take the vector A, which is the first vector given in this particular question, and write it separately in such a way that direction as well as magnitude should not be altered. So I'm going to shift this over here. So this is my vector A. So I'm going to write vector B towards vector A in such a way that the tail head should be interconnected. So I'm gonna merge this towards here, towards here. I'm gonna see that whether they are in the form of tail head fashion. So we have tail head. Yes, it is there in the form of tail head fashion. So suppose A plus B equal to C vector. So this new C vector is going to be in such a way that the tail of the first vector plus head of the second vector should be connected, and towards the second vector you should write the head. So this vector what you're going to see here, this is going to be your C vector. Now student must be having a doubt, what if we do B plus A? What if we reverse this particular order? What is going to happen? So let us see that also. So we're going to do B plus vector A. So as I told you, as the sequence goes, you have to add the particular vectors. So first you have B vector, going to write it separately without altering any direction or magnitude. So this is vector B, and vector A you're going to write in such a way that it should be in the form of tail head fashion. So tail head, and I'm gonna shift it towards here in the form of tail head fashion. So the next thing what I'm going to do is I'm going to write in such a way that the tail of this and head of this are interconnected, and I'm going to write say arrow towards vector A. So this is how my vector C is going to be. Now if you compare towards the previous example, so I'm going to write it again. So this is vector A, this was vector B, and this is how was vector C. Now you can see these two particular vectors are equal. So from this I can conclude that A vector plus B vector is equal to B vector plus A vector. So this law can be will be obeyed in triangular law of vector addition. You can use this particular law to prove this. Also, if you add A vector plus B vector and then add with C vector, it is going to be equal to adding A vector by adding B plus C vector first. So this is the second law which you have. I don't remember commutative or associative. I don't remember that particularly right now. But this is the law which you need to be knowing about. Come on, gentlemen, we're not going to we're not computers, can't remember everything. All you need to know is the basic concept and you should be able to apply them. That's the main goal of learning anything. Okay, now let us see what happens if you multiply a vector with a particular number. So that number could either be positive or negative, or it could be 0. So suppose I take this as my example. So this is my vector A. Suppose I multiply this vector with 2. Suppose I write 2 into vector A. So what happened? The vector length got doubled. So in this particular same direction, the length of the vector got doubled. So I'm going to write this new vector as a vector which is in the same direction but twice the length. Now suppose if I write 3a. So this is like multiplying 3 to the first vector. So the length of this particular vector will be 3 times the length of this particular vector. So this is how this vector is going to be. The direction is going to be same, but the magnitude will be changing because you're multiplying with a particular number. So suppose if I multiply it with 0.5 into A. Now this length is going to be half of this length. So this is how I'm gonna write this. Now what if I multiply this vector with a negative number? So let's see what happens in that case. Okay, I'm gonna write this here. So suppose if I write negative vector A, so it is negative 1. So if you multiply negative number to the vector, original vector, what happens? The direction reverses and the length of the vector will be adjusted accordingly. Here it is 1 into A, which is original length, but since it is negative, I have to reverse the direction of this original vector. So this is how my minus A is going to be. Now if I write minus 2A, it is nothing but twice the length of this particular vector, but in the same direction. Now if I write 3a minus 3a, so 3 times the length of this particular vector, which is this much. So if I write minus 0.5a, half of this particular length, so half of this. Now what if I multiply it with 0? The vector simply vanishes, you get a 0 vector or a null vector. So if a vector has 0 magnitude or undefinable direction, it is said to be a 0 vector. So if I say 0 into vector A, it's nothing, just nothing. There's no vector there. So this was the basic introduction of vector. So now let us see what is subtraction of vector means. So subtraction of vectors is indirectly addition of vectors. So now let us see how it works. So suppose this is my vector A and this is my vector B. So you should be able to remember the triangular law of vector addition in order to understand this. So I hope you're making notes of this particular thing. Please make notes in order to understand further concepts. So suppose I write vector A minus vector B. So according to triangular law of vector addition, I have to take vector A first and write it separately. So this is my vector A, I'm going to write it separately. So this is my vector A. So I'm going to modify this particular equation into a different form. So this is vector A plus of minus vector B. Now see, if you multiply plus into minus, you're going to get your minus back, which is this original equation. So there's no problem of me modifying this particular equation in this way. So I'm just basically adding vector A with minus of vector B. So do I have minus of vector B? No. Now as I told you before, if you multiply a vector with a negative number, the direction reverses, whereas magnitude changes accordingly. Since you have minus 1 into B, so minus 1 into B, which is nothing but minus B. So I have to revert this particular vector So reverse without altering the length. So this is my minus b. So I'm going to erase the remaining stuff. So then what I'm going to do, I'm going to just basically add vector minus b to vector minus a using triangular law of vector addition. So this is your minus a. So sorry, this is your plus a. I have already written it over here. Then your minus b you have to add in such a way that it should be in the form of tail head fashion. So tail head. So I have to shift this towards here and write it in the form of tail head fashion. So it is written in that form. Then what I'm going to do, I'm going to take the tail and head of these two particular vectors and I'm going to join them, and I'm going to write the head of this particular new vector towards this particular vector, which is, I mean, the second vector. So this is going to be my c vector, resultant vector. So this is how you're going to subtract two vectors. It's very simple. Just have to know what happens if you multiply a vector with a negative number and just add accordingly. So previously I told if you have two vectors, you can use triangular law of vector addition to add or subtract those vectors. Now what if you have more than two vectors? So in order to solve that particular problem, we have a polygonal law of vector addition or tail-head method of vector addition. So for that we have to know polygonal law of vector addition, or you can call it as tail-head method. I would prefer calling this because you can use this to remember this particular method. So suppose I have say I'll take four examples, four different vectors. So this is my vector a, and this is my vector b, and this is my vector c. So it's same, change the direction. So this is my vector c, and say this is my vector d. So my question is, you have to a plus b plus, say I'm going to take it minus c plus d. So how are you going to do this? This sounds extremely difficult when you see this for the first time, but not now because I am there. I'm going to explain it to you very easily. So first, take the first vector, which is vector a, and write it separately. So you wrote this. Then just normally add second vector in the form of tail head fashion. That's it. So I'm going to shift this over here in such a way that it is in the form of tail head fashion. So this is my vector b, and then what they're asking minus c. As I told you, I can write this particular equation as a plus b plus of minus c plus d vectors. So I just basically have to add minus c vector. But do I have minus c vector? Obviously not. So that I have to create it. So you have plus c, the minus c is going to be just like this. So as I told you, you have to reverse the direction without altering the magnitude. So now I'm to add vector c here. So now my next vector is vector c in such a way that tail head fashion. So I have to shift this till here. So this is my vector c, vector minus c, my bad. So after adding minus c, next vector is plus d. So I'm going to take this and write it in such a way that it forms tail head fashion. Now what if we had one more vector, say plus vector e, say suppose that vector is in this form, say this is vector e. Nothing, simple, just take this and add it in the form of tail head fashion. So I'm gonna add this over here. So this is my vector e. It's that easy, guys. Even though it sounds to be very difficult, it's very easy thing to understand. So then next what I'm gonna do, so this is my first vector and this is my last vector. So the tail of this and the head of this, I have to join them. And I have to write the head towards the last vector. So this is going to be my resultant vector. So it is extremely easy. Since it looks like a polygon, they named it as a polygonal law. And since the methodology used here is tail head method, you can call it in that way also. So this is how you're going to add two or more vectors. Okay, previously we saw how you can add two vectors or subtract two vectors, or add or subtract two or more vectors geometrically. Geometrically. So now we're going to see how you can add two vectors analytically, which is by using more mathematical numerical forms. So let's get started. So suppose you have two vectors. So I'm going to call this as vector A, and I'm going to call this as vector B. Now, as I told you, the angle between two vectors is, if you join the tail of two vectors, and see the angle what you get there is the angle between two vectors. So I'm going to do that. So I'm going to join the two tails without altering any direction. So that should be in your mind. You shouldn't alter any direction. You should just do it as a copy paste, just like shifting this till here. So next what I'm going to do, I'm going to draw a parallelogram here. So I'm going to draw a parallelogram in such a way that it forms so this side is parallel to the vector A, whereas this side is parallel to vector B. So since this has same magnitude as well as direction of this vector, I can call this also as a vector B. So similarly goes for this also. I can call this as a vector A. Now this is my angle between two vectors, which is theta. Now if I use some geometry, I can call this as my vector C, which is my resultant vector. So my main objective is to find the magnitude as well as direction of this particular vector. So as I told you, direction you can use many things. You can either say verbally by saying north, south, northeast, northwest in that form, or else you can represent in the form of theta and say in the form of Cartesian plane, or in that form also. Here we are using theta in order to represent the thing. So suppose this angle is, I'm going to write it as delta. So this is delta. So my main aim is to find the magnitude of C, which is my resultant vector, and delta value. Now if you apply some math, if you apply some trigonometry and math, which is which I'm not going to teach it over here, you can find the length of C to be, so magnitude of C is going to be square root of magnitude of A square plus magnitude of B square plus 2 into AB cos of angle between these two vectors. So this is A, this is B, this is the angle between two vectors. So suppose A has the magnitude of A, either you can write, either you can write in this form or in this form. So two ways. So magnitude of C vector is going to be A square plus B square plus 2AB cos theta. So how will you remember this? You know A plus B whole square, right? So A plus B whole square formula you probably know about, which is A square plus B square plus 2AB. Now instead of simply, so you take this square and you root this off, and instead of this A plus B, you write it as C, magnitude of C, or simply C, and instead of simply leaving empty here, you multiply it with cos theta. Now the exact derivation of this particular formula is given in your NCERT textbooks. You can go and refer that. I'm not going to teach it over here. I know how to teach, but I'm not going to waste time teaching that. So this is the magnitude of this resultant vector, which is A vector plus B vectors magnitude. So, and then what I'm going to get delta as, which I told you, delta is the angle between. So I'm going to write it over here on the diagram. So I'm going to mess everything. This is my vector delta. This is the angle between two vectors. So this is vector A, this is vector A, and this is vector B, and this is the angle between two vectors, whereas this is the delta, which is angle between vector C and vector base vector. So this value of delta is going to be, so tan delta is equal to, so if you derive this, you're going to get in the form of tan. So tan delta is equal to, so delta value is going to be A sin theta divided by B plus A cos theta. Now how will you remember this particular formula? You know tan equal to sin by cos. So what are you going to do? You simply going to write it as sin by cos. Sin, since this is theta, remember theta is the angle between A and B, whereas delta is angle between base vector and the resultant vector, which is C. This is your C resultant vector, this is C vector. So know the difference. So tan, you know, you're going to write it in the form of sin theta by cos theta. So sin theta by cos theta, sin theta by cos theta. And so after writing in the form of sin plus cos, so you write plus and write the magnitude of base vector. Remember base vector. Normally this switches sometimes, but you should be aware that the magnitude which comes here is the magnitude of the base vector. Base vector. In this case, base vector is B. So magnitude of B vector, and the coefficient of these two trigonometric functions, you're going to write it as A and A. Remember, A is your adjacent vector, whereas B is your base vector. So B plus A cos theta plus A sin. So A divided by B plus A cos theta. So this is how you're going to remember this particular formula. I have made it very easy for you. And these two formulas are extremely important. Extremely important. I can't stress you out how important these two formulas are. You can solve literally any problem in vectors using these two particular things. So I want you to by heart anything, by heart or practice or do whatever you want. I want you guys to remember these two particular formulas. I've already told the method in which you can remember, but still some people tend to forget that things. So just a reminder for you guys. Okay, now let us solve a problem on the previous two formulas which we derived. Some of them might skip this particular part. No, you should not skip. You should solve problems, because without problems physics is just meaningless. So yeah, let's get started. So the question says vector A and B makes 20 and 110 degree with the x-axis respectively. So the main thing which you need to know in order to solve problems in physics is understand the questions properly. So now let us understand the question. So vector A makes 20 degree with x-axis, whereas vector B makes 110 degree with the x-axis. This is what the question, this is the first sentence of the question means. Okay, now let us see how it does. So this is the x-axis. So we have, this is x-axis. So this is the origin. I'm not going to write the y-axis because it's going to confuse you. So 20 degree with the x-axis means, so this is my vector A. So this is my 20 degree. Whereas 110 with x, so vector B somewhat above 90, since 110 is more than 90. I'm going to write it as bit backwards. So this is my vector B and it makes 110 degree. So this is my 110 degree. Now, what is the angle between two vectors? It is not directly given. We have to find it. So let us see how we can find. So let me take this angle as a theta. As you know, angle between two vectors is theta. And are they joining at the tail? Yes, they're joining at the tail. So this is my angle between two vectors. So how do we find theta? We're going to use some math. So the total angle given here is, so I'm going to take, so theta. So is it, so if you use your brain a little bit, isn't theta plus 20 equal to 110? Isn't theta plus 20 equal to 110? Just see, theta, if you add with 20, you're going to get this whole angle as 110. So from this equation I can solve what theta is. So theta equal to 110 minus 20, whereas theta equal to 90 degree. So we found the angle between these two vectors as 90 degree. So I skipped the little part of the question. The magnitude of vector A is 5, whereas magnitude 5 meters, whereas magnitude of vector B is 12 meters. I skipped this, so sorry on that, please apologize. Okay, I'm gonna erase this and write the better diagram. So we found out the angle between these two vectors is 90. So 90 means it is going to be somewhat like this. So this is my vector A, this is my vector B. Magnitude of this particular vector is 5 meters, whereas magnitude of this particular vector is, so magnitude of B equal to 12 meters. Now the angle is 90 degree, which is theta. So they're asking us to find the magnitude and direction of the resultant vector. So the resultant vector is going to be in this. So this is my B vector. So A plus B is, say suppose C. So this is my C vector. So okay, now let us use the formula to find. So C vector equal to, magnitude of C vector equal to square root of A square plus B square plus 2AB into cos theta. So theta equal to 90 degree. Magnitude of A is 5, magnitude of B is 12. And erase this and write it over here. Magnitude of B equal to B is equal to 12 meters. So after substituting everything in this particular equation, so A is 5 square and B is 12 square plus 2 into 5 into 12 into cos of 90. So I hope you remember the values of trigonometry. So this is 25, this is 144 plus cos 90 is 0 if you remember. If you don't remember, please go and check out the table, or I'll make a separate video of how we can remember this particular values, which is a concept for our next video. So please wait for that. Hit the subscribe button, bro. What are you watching simply for free? Subscribe. So 25 plus 144 into, sorry, plus 0. So this is nothing but 169. So root of 169, if you remember, it is 13. So root of 169 is 13. So my answer is going to be 13 meters. Remember, unit is extremely important. If you don't write units, they're going to cut your marks. So since this question is given in the form of meters, I'm going to write it as meters. So I have found the magnitude of resultant vector, which is 13 meters. So now let us find the direction of this resultant vector. So I hope you remember the formula. So tan delta equal to remember sine by cos, so sine theta by cos theta, plus this vector is always going to be your base vector. So in this case, the base vector is A. So that's why I told you to remember in this way. In this way, you don't make any mistake. So sine theta plus cos theta, as you know, tan theta equal to sine theta by cos theta, and plus this vector is your base vector magnitude. So base vector in this case is vector A, whereas the coefficient of these two is going to be your remaining one. So in this case, it is B, B, B. So B is 12 into sine of 90 degree plus 5 plus 12 into cos of 90 degree. So theta, my bad. So this is going to be 0. So totally this term is going to be 0. So 12, and since sine 90 is equal to 1, so 5. So tan delta equal to 12 by 5. So this is how you're going to leave it. You don't know the value of tan delta equal to 12 by 5. You have to use inverse trigonometric functions, which is again a concept for a next video. Another video, not next video, my bad. I'm going to make it in a different del. So tan delta is equal to 12 by 5, or tan equal to tan inverse of 12 by 5. So if you put this back, you're going to get your tan back. And if you want to find the theta, if you want to find theta using the trigonometric value, you're going to take inverse. So this is called inverse trigonometric function. So you can use the trigonometric table or Clark's table in order to find the value of this. So use a calculator and find what is 12 by 5. You will get in the form of decimals and go to the table and check what is coinciding with the theta value, and then write it over here, which I'm not going to do it today. Normally, if you write it till here, they're going to give the full marks. So no need to worry about the table and things. So that's it. That was the that was the first part. I hope you understood everything which I explained in this particular video. If you learned something new, make sure you subscribe to my YouTube channel. And whatever the concept you want me to teach, let me know in the comments. And I'll meet you in the next video. Thank you.